Chapter 1.3, Combining Transformations, Part 1. Transformations from our previous lessons can be combined together. This creates multiple transformations on a function, and we can use the following forms. The first form has y isolated. The second form has the k value with the y, so y minus k on one side of the equation, and the other three parameters on the other side. Investigate. Does the order that you do the transformations matter to the final graph? Example. Given the graph of y equals f of x, sketch the transformed graph after the following transformations are performed in order. A, reflected in the y-axis, then translated 3 units to the left. So reflected in the y-axis, it's reflected horizontally. Reflecting in the y-axis takes our points xy on the original function and changes them to negative xy on the transformed function. So if I start with the point on the left side here, that's an x value negative 2, so the x value would become positive 2. The next point has an x value of negative 1, so the x value when reflected across the y-axis would become positive 1. Next point has an x value of 1 reflected across the y-axis, and we get negative 1 for x. Then we have an x value of 3, reflect that across the y-axis, and we get an x value of negative 3. And finally, an x value of 4 reflected across the y-axis gives us an x value of negative 4. And we can join those points together. Then the next transformation is that the graph is translated 3 units to the left. Then a point xy on the reflected graph will become the point x minus 3y on our final graph. So starting at the left, this point gets shifted over 3 to be here. Next point shifted over 3 will land here. This point shifted over 3 will land here. This one shifted over 3 lands here. And last one, shift this over 3 and it will land there. And then draw our lines to finish the graph. So this graph is our graph that was reflected and then translated. B, translated 3 units to the left, then reflected in the y-axis. So first we're going to translate, so move each point 3 units left. First one's going to be here. This one's going to go here. This one will be here. This one will be here. Last one, this one will be here. Join our points together. That was our translated 3 units, so point x, y would become x minus 3, y. Next, we're going to reflect that new graph in the y-axis. That takes our point from the translated graph, xy, and makes it negative xy. So this point is at negative 1, 2, 3, 4, 5, so it'll be at positive 1, 2, 3, 4, 5, so it'll land here. This point's at negative 4 for the x value, so it will be at positive 4. This point's at negative 2, so it will be at positive 2. This point is at x equals 0, so it'll stay at x equals 0. Remember, that's called an invariant point. And last one, this one is at x equals 1, so it's going to go to x equals negative 1. And then join our points together. So this graph is translated and then reflected. Did the order in which the transformations were performed make a difference on the final graph? Yes, because our graphs are not the same. So doing the same transformation in different orders resulted in different graphs. Therefore, the order of transformations is important. Based on the final image graph, how would you write the equation of the graph in y minus k equals af bracket b bracket x minus h close bracket form? So let's list our parameters. A, we didn't have any vertical stretch or reflection, so A equals 1. Our B, there was no stretch, but there was a reflection, so B is negative 1. H, we shifted left 3, so that's negative 3. And K, there is no vertical translation, so K is 0. And our function becomes y minus k, which is 0, so just y, equals a, which is 1, don't need to write that, f bracket, b is negative 1, I can just put a negative, and then x minus negative h would be x plus h, close bracket, and there's our function. This is Editing Corey here. I found an error. This h was supposed to be 3. We have h is negative 3, so x minus negative 3 would become x plus 3. So let's replace this h with the number 3. As the video continues, on this page you will see that it does still say h instead of 3, but just know that it should say 3, not h. Order of transformations. The order of operations when performing transformations is 1. Do your stretches, then do your reflections, and then your translations. Stretches and reflections actually you can do in any order. That actually doesn't matter. But your translations you have to do last. So you have to stretch and reflect before you can translate. So use that order, stretch, reflect, and then translate unless otherwise specified. So for this particular question here, it said translate to the left and then reflect. So then we would do it in that order. But if it doesn't say differently, then you're always going to do your stretches and reflections first and your translations last. Note, always make sure the equation is in fully factored form. The mapping notation for transformations based on y equals a f bracket b x minus h close bracket plus k is a point xy on the original function goes to 1 over bx plus h and a times y plus k. You could also write the x part as x divided by b plus h. It means the same thing. Example, describe in order the transformations represented by each equation. Write down what each value is and what it represents. A, we have y plus 5 equals 4f of negative x. I'm going to move that 5 over by subtracting 5. Then I get y equals 4f of negative x minus 5. Then I have an a value of 4, and a is a vertical stretch factor of 4 about the x-axis. B would be negative 1. So there's no stretch factor since b is 1, but because it's negative, that means that there is a reflection across the y-axis. And then we have that k equals negative 5, which is a vertical translation down 5 units. B, y equals negative f bracket 2x plus 14. This, you should see, is not factored, so you need to make sure that you factor. Then it becomes y equals negative f bracket, we can factor out 2, then we have bracket x plus 7 close bracket close bracket. So now we have that a equals negative 1, which is a reflection across the x-axis. We have that b equals 2, which is a horizontal stretch factor of, remember it's the reciprocal of b, so 1/2 about the y-axis. And then h, since it's x plus 7, h is negative 7, which is a horizontal translation 7 units left. C, y equals 1.75 f bracket 0.25 bracket x minus 1.5. We have an a value that equals 1.75. That represents a vertical stretch factor of 1.75 about the x-axis. Then we have b equals 0.25, which is a horizontal stretch factor of the reciprocal of 0.25, which would be 1 over 0.25, and 1 divided by a quarter equals 4. So the horizontal stretch factor of 4 about the y-axis. And then we have that h equals, it's x minus 1.5, so h is 1.5, which is a horizontal translation (1.5 units right). dy minus 4 equals negative 1/2 f bracket negative 3x minus 3. Should see that this bracket is not factored, so we need to factor that. If there's anything other than 1 in front of the x, it should be separated by a bracket to show that it's been factored out of this binomial. Since there's a number in front of x, but there's no brackets, we need to factor that out. Even if the number in front of x is not a common factor for this binomial, you would still need to factor this out of this binomial. So I'm also going to add 4 to both sides. Then we have y equals negative 1/2 f bracket, factor out negative 3 bracket, we get x, and then negative 3 divided by negative 3 is positive 1, and then we have plus 4. So our a value is negative 1/2, which is a vertical stretch factor of 1/2 about the x-axis, and also it's negative, so it's also and a reflection across the x-axis. Then b equals negative 3, which represents a horizontal stretch factor of the reciprocal of the absolute value of b, so 1 over 3 about the y-axis. Also b is negative, so it's also a reflection across the y-axis. Then we have h, it's x plus 1, so h is negative 1, which represents a horizontal translation one to the left since it's negative. And then finally k equals 4, which represents a vertical translation 4 up. And just a note for the diploma, when you're writing the diploma, don't use any abbreviations. So VSF for vertical stretch factor, actually spell out vertical stretch factor, because the markers will not accept abbreviations. So even though they would know that this is vertical stretch factor, you have to write the words vertical stretch factor, just like we write vertical translation. Okay, so just write everything out in full words for the diploma. Example, determine the equation of each transformed function. A y equals f of x is stretched horizontally by a factor of 6. So that's the b value. If it's a horizontal stretch factor of 6, Then b is the reciprocal of that, which would be 1 over 6. It's reflected in the x-axis. That tells us that a is a negative. And it's translated 7 units down, so k is negative 7. Since it didn't have a vertical stretch factor, we know that a is negative, so a would just be negative 1. Then we get y equals a, which is negative 1, so just negative, f bracket our b value, which is 1 over 6, times our x. You can put brackets around the x or not. In this case, it doesn't matter because we don't have an h value. And then close the bracket and then minus 7 for the k value. Or you could also write it with the k value on the other side with the y. So then we would add 7 to both sides and it would be y plus 7 equals negative f bracket 1 over 6 x. And again, you could put brackets around the x or not because we don't have an h value. It doesn't matter in this case. So either one of those would be fine. by equals the absolute value of x is reflected in the y-axis. That means that b is negative. It's stretched vertically by a factor of 1/2. So a equals 1/2, and it's translated 3 units to the right, which means h equals 3. There is no horizontal stretch factor. Since b is negative, b equals negative 1. Then we have y equals a is 1/2. Then absolute value of b, which is negative 1 or just negative. And then we have bracket x, and then h is 3, so minus 3, close bracket, close the absolute value. And there's our transformed function. See, y equals x squared is reflected in the x-axis. That means a is negative, stretched horizontally by a factor of 3. Then b is the reciprocal of 3, which is 1 over 3, and translated so that the vertex is at 10, negative 4. Doesn't tell us what h and k equal, but we know that there is a translation. Since there is no vertical stretch factor, a is negative, so a equals negative 1. Then to figure out our translation or translations, could have a vertical and a horizontal translation. We know that the vertex of y equals x squared is at 0, 0. And we know that that point is going to be mapped to 10, negative 4 on our transformed function. So how do we get there? Well, a point x, y on the original function would become the point x divided by b plus h, and a times y plus k. In this case, we have 0, 0 would go to 0 divided by b plus h, and a times 0 plus k. Because our point is 0, 0, those values do not get affected by stretches or reflections. So they're going to stay 0 for that part. So then this just becomes hk. So since 0, 0 is mapped to the point 10, negative 4 in our transformed function, and we see that 0, 0 is not affected by any stretches or reflections. Then h would be 10 and k would be negative 4. Then we can write our equation. Y equals a is negative 1, so just negative, bracket b is 1 over 3, bracket x minus h, which is 10, so x minus 10, close bracket, squared, and then minus 4 for the k value. We can also write it with the k value on the other side with the y, so we'd have to add 4. We get y plus 4 equals negative, bracket 1 over 3, bracket x minus 10, close bracket, squared, minus 4. Hello, this is Editing Corey here. I just noticed that right here I wrote the minus 4 when I shouldn't have wrote that because we moved it over. So that minus 4 on the right hand side should not be there anymore. So let's just erase that. So when you continue on with the video, it will show the minus 4 still, but just know that that's an error. It should not have the minus 4 on the right hand side. Example, the key point 110 is on the graph of y equals f of x. Determine the coordinates of its image point under each transformation. A is y plus 4 equals f of x minus 5. I'm going to move the 4 over by subtracting 4 from both sides. Then I get y equals f of x minus 5 minus 4, which gives me an h value of positive 5 and a k value of negative 4. Then xy would be transformed to the point x plus 5, y minus 4. So 110 would become 1 plus 5, 10 minus 4, 1 plus 5 is 6, and 10 minus 4 is 6, so we get the point 6, 6. B, y equals negative f of x plus 12. A is negative 1, and h would be negative 12 here. Then the point xy is mapped to the point x minus 12, negative y. The point 110 becomes 1 minus 12 and negative 10, which equals 1 minus 12 is negative 11 and negative 10. C, y equals 3, f of 0.5x plus 10. Notice that our brackets are not factored. We need to factor out the coefficient in front of x. We get y equals 3 f of 0.5 bracket x plus 10 divided by 0.5 would be 20, close bracket. Then a equals 3, b equals 0.5, which is 1/2, which means our horizontal stretch factor equals the reciprocal of b, which is 2. And then h, x plus 20, h is negative 20. So the point xy would be mapped to 2x minus 20, and y would be 3y. Then the point 110 is 2 times 1 minus 20, and 3 times 10, which equals 2 times 1 is 2, minus 20 is negative 18, and 3 times 10 is 30. So negative 18 and 30. The following transformations are performed on the graph of y equals f of x to obtain the graph of y equals g of x. Vertical stretch by a factor of 6 about the x-axis. That gives us an a value equal to 6. Reflection in the x-axis, that means a is negative, so a equals -6 then. Vertical translation of 5 units down, that gives us a k of -5, and a horizontal translation of 3 units left, which gives us an h equal to -3. Write the equation of g of x in terms of f of x. G of x equals -6, the a value, then f of, there's no b, we have x minus -3, so x plus 3, close bracket, and then we have minus the k value, which is 5. B, if point C42 is on the graph of f of x, using mapping notation, find the coordinates of the point on g of x. A point x, y on f of x would become, we don't have a b value, so x, we have h is -3, x minus 3, a is -6 times y, and then minus 5, which is k. Then the point 4, 2, that's on f of x would become 4 minus 3, comma, -6 times 2 minus 5. And that is 4 minus 3 is 1. -6 times 2 is -12. Minus 5 is -17. Part C, given that f of x equals the square root of x, write the equation for g of x in terms of x. So we had g of x is -6 f of x plus 3 minus 5. Now we know that f of x is the function square root of x. So g of x can be written -6, replace the f with the square root function because that's what f of x is. X plus 3 goes under the root, and minus 5 outside the root. That brings us to the end of Chapter 1, Lesson 4.